NumPy is the fundamental package for scientific computing with Python. NumPy contains a powerful n-dimensional array object, sophisticated broadcasting and universal functions, useful linear algebra, Fourier transform, and random number capabilities. And besides its obvious scientific uses, NumPy can also be used as an efficient multi-dimensional container of generic data. And arbitrary data types can be defined. This allows NumPy to be seamlessly integrated with a wide variety of databases. So NumPy is a scientific data package or data library that we use with Python, and the most powerful feature of NumPy is the array object, n-dimensional array object. So along with that, we have the useful linear algebra, Fourier transform, and random number functions that allow us to perform linear algebra and other features on the objects contained within the NumPy framework. So it is basically mostly used in scientific platforms, and it is also helpful in machine learning models. So we'll be discussing NumPy arrays in general. Whatever is in a container like object in Python can be converted to n-dimensional ND array in NumPy. So this uses the array function here to accomplish that conversion. So if we have this civilian birth as np.array and within that a list in Python, it will convert it to an array of uh, object elements. So basically we write like this: import numpy as np. So numpy is the library, and as np means it is an alias. Np is the alias for numpy. So whenever you want to use numpy, we simply write np dot and use the method. Now to create special arrays in NumPy, we use methods like zeros and ones that take an argument as number and creates those number of ones or zeros in the resulting array. So if we give two numbers separated by comma, it will result in a two-dimensional array having 3 rows and 6 columns and so on, and all the elements will be zeros in this case and ones in this case. And if we write a numpy array to be converted to list, we can use dot to list, and it will convert the array back to list. So to reshape arrays in NumPy, or rather to reshape NumPy arrays, we can use the reshape method here that will reshape in the specified format as passed as parameters to that function. So considering we have an array like this, which takes from a range from 0 to 9 inclusive, and this is a single dimensional array, it we reshape it to double dimensional array having 2 rows and 5 columns, and we print array dot shape, it will print 2 5, and print array, it will print something like this: 2 rows and 5 columns. And if we reshape it to 5 rows and 2 columns, it will be printed something like this: 5 rows and 2 columns. Moving on to NumPy stack arrays, we can stack one array over other either horizontally or vertically. So we can use the stack here function, for example, that will stack b over a. So example is shown here, and we can generate random numbers from NumPy. The function is random, and we can either use the normal method or uniform method. So uniform generates 4 random numbers from the uniform distribution, and normal generates 4 random numbers from the normal distribution if we give size is equal to 4 in the parameter list. And that is, size defines the number of random numbers this it will output. And if we want to print a random integer between 1 and 100, and 4 random integers. In fact, we can give size is equal to 4, low is equal to 1, and high is equal to 100 in this uh, function random integer of this NumPy module. So it will print an array of 4 random integers between 1 and 100. NumPy matrices. There is also a matrix class that inherits from the ND-array class. So there are some slight differences, but matrices are very similar to general arrays. In NumPy's own words, the question of whether to use arrays or matrices comes down to the short answer of use arrays. So to demonstrate the difference, we have this example here. So we first import NumPy as NP and create a vector or array from the array method and assign it to vector, and create a matrix from the np.matrix method and assign it a matrix here. And if we write vector.t, that dot t is to take the transform of that specific object. So it will simply create output array as it is in the array case, and in the case of matrix it will output the transpose of the matrix. So that's the difference. So how do we flatten a matrix? So flatten a matrix means to reduce the dimensionality to a single row. So it will, we can simply write matrix.flatten. Flatten is the function name. It will simply reduce the dimension from 3 to 1 in this case, and basically it will reduce the dimensionality to a single row. So in this slide we discuss NumPy dot and inner differences. So dot and inner are two functions in NumPy that generate dot products and inner products of their corresponding parameter objects. So if we have two array objects as like this, and we write np dot a comma b, it will produce output as this, where the differences is shown here. With dot product, it is taken over row by column way, and in inner product it is taken as row by row way. So with inner it is 1 into 11 plus 2 into 12, then 1 into 13 plus 2 into 14. So it is row wise, and this is column wise separation. Hope this is clear. Next, we discuss some linear algebra operations with NumPy. So we can take the determinant of a matrix with the help of this function linear algebra dot determinant. So dot linear algebra, or LINALG, is the function in a NumPy that allows us to perform or the module rather in NumPy that allows us to perform various linear algebra operations on matrices and other objects. So we can do all of these: calculate the trace of the matrix using sum, diagonal dot sum, calculate inverse of a matrix using inverse, add to matrices using dot add, and subtract to matrices using dot subtract. So next we see eigenvalues and eigenvectors in NumPy. So we can simply import EIG from NumPy.linearAlgebra and write EIGA, where A is the array here. It will show the eigenvalues and eigenvector here. So we can use linear algebra with NumPy for solving equations. Suppose we have this set of equations on the right side here. So the first equation left side can be written in the first row of this array here, and the second row can be written as the second row here, I mean the left hand side, input side, and the right hand side can be written as another array, 23 and 3 here. And we can simply write x is equal to solve a comma b. It will give the output for x as array 2 3. So this is the x value and this is the y value. So x is 2 and y is 3.